Let's see another problem on Dtft, wherein x of n is equal to half raised to n into u of n minus 4. By considering the analysis formula, we write x of e raised to j omega as summation n from minus infinity to plus infinity x of n e raised to minus j omega n. So by substituting this x of n as half raised to n u of n minus 4, but half raised to n will write, and in place of u of n minus 4, we know u of n minus 4 is a discrete non-periodic signal and runs from 4 to infinity. Means we need to write it from 4 to infinity instead of minus infinity to plus infinity. And this half raised to n e raised to minus j omega n as it is. E raised to minus j omega n as it is. So by combining these two, we get in this fashion 1 by 2 e raised to minus j omega, this all raised to n. And by the formula, if n is equal to 4 to infinity, then we need to write it as 1 by 2 e raised to minus j omega raised to 4 divided by 1 minus half e raised to minus j omega. By the formula, if k is from n to infinity, alpha raised to k, when alpha is less than 1, then it is alpha raised to n, whatever is this lower limit, divided by 1 minus alpha. So by that property, we'll write this one. And here the magnitude of this one is so, and the phase of this one is given by, so here we have from the top, it is e raised to minus j omega 4. Omega is e raised to j is the angular factor. So whatever is e to the power of minus j, that we have to consider. So minus of omega, and this we know that e to the power minus j omega raised to 4 is nothing but e to the power of 4 minus 4 j omega. So 4 omega divided by minus this tan inverse of this e raised to minus j omega can be written as sin omega, and from this it would be, so as there is 1 by 2 here, so we get this one half and 1 by 2 get multiplied, so we get the phase as this much. So similarly we can go for other problems. Then the next very important problem is, even similarly, half raised to n u of n plus 4 can be learned. So one can try here to make this lower point as a 0. We do the same process, n plus 4, it is minus 4 to infinity. So but for minus value we don't have that formula. Let's make this below minus 4 as 0, and to make that one, m is equal to n plus 4 we are taking, so that when n becomes minus 4 plus 4, it would be 0, m becomes 0. Then we can write this one as m is equal to 0 to infinity m minus 4. So we take this one outside. We can solve in different ways, so this is also one of the way, and by using the formula we can solve this. The very important problem in Dtft is this one. X of n is equal to a to the power magnitude of n, where magnitude of a is less than 1. Now x of e raised to j omega summation n from minus infinity to plus infinity x of n e to the power minus j omega n. So here summation n from minus infinity to plus infinity will write e to the power magnitude of n will substitute, and e to the power minus j omega n. Now the thing is, we are well aware of the nature of this magnitude of n. So this a is less than 1 means when we have a 0 here, and this is the range wherein n is greater than 0, and this is the range where n is less than 0. So when we have these things. When n is greater than 0, I mean this is a raised to n itself, and when n is less than 0 also it is a raised to n itself, as we know. So a raised to n, and this factor is less than 1, so we have this is a decaying exponential, because when n is equal to 0 its value is 1, and when n is 1, so it goes on decreasing in this fashion. So this kind of a exponential signal is this a raised to magnitude of n and runs up till infinity. And what about this minus range? Even it is same, because we know magnitudal signals are always even signals or symmetrical signals. They are symmetric about the vertical axis. So this is our a to the power magnitude of n, and the values of this, so the signal is given by a to the power minus n. So the signal has to be given by, it is a decreasing signal, so it is a to the power minus n, and this will be given by a to the power n, because n is minus 1, then it becomes, it would be this kind of a signal. Let's try with a is equal to 0.5. When a is 0.5, then when n is a 0, 0.5 raised to 0, we get this is 1. When this n is equal to 1, then it is 0.5 raised to 1. So 0.5 raised to 1 will be 0.5, means it should not be minus, it should be plus. So a to the power n, or it is equal to a raised to n is the signal. Similarly, when n is equal to 2, so this will take, when n is equal to 2, the signal will take a to 0.5 raised to 2. 0.5 square is 0.025, so it is again lesser than that. So it is 2, a to the power n, and on this side, when n is minus 1, so it has to become 0.5 raised to minus 1, means it is 1 by 2. So for that, let's take the signal when n is equal to, now a to the power minus 1 will become, it is 0.5 means it is 1 by 2, and when we write this one as just 1 minus 1, then because n is minus 1 here, when we write this one as minus 1, then the signal will become 2, and we are not supposed to have 2 here, means it should be minus, a to the power minus. So a to the power means n is minus, minus of minus, it would be plus, it remains half, so it is an even signal. The conclusion is, on the left side, from minus infinity to 0 we can say, or up to minus 1, the value of the signal is a to the power minus n, and from 0 to infinity its value is a to the power plus n. Let's see what is there. And this, okay, so the problem is this one only, a to the power magnitude of n. So when we solve this, yeah, n is from infinity to minus 1 over this range, from minus infinity to minus 1, it is a to the power minus n, e raised to minus j omega n, plus from n is equal to 0 to infinity, it is a to the power n e raised to minus j omega n. Then the rest thing would be same. So 1 to infinity, a into e raised to j omega, and this n. So what has been done over here? So let me tell. This is not being changed, but here what we do is n is equal to, let's rewrite, and so the summation would be, the summation is a to the power minus n, e to the power minus j omega n, a and e to the power j omega are being written raised to minus n, and the same limit. Only with the first term we do these things. So let n is equal to minus n, when we make n as minus n, means we are replacing n with minus n. So this becomes n is equal to plus infinity, because n has been replaced with a minus n. And the same here, it will be 1. And it is a e to the power j omega as it is, but n has been replaced by minus n, means this minus n will go plus n. And this here, we modify this one, and the summation will be always having the lower limit, means we write it as n is equal to 1 is smaller than infinity. We write the lower one at lower place, and summation upper infinity, and this alpha a into e raised to j omega raised to n. And this can be solved as with the formula this will. So it is a into e to the power j omega divided by 1 minus e into e to the power j omega. That's it. So this modification is done with the first term. So we get this one as a into e to the power of j omega, 1 minus a into e to the power j omega. That's it. And the second term solution, we know 0 to infinity it is running, it is 1 by 1 minus a into e to the power minus j omega, as a is less than pi. So when we solve this, we know 1 minus e to the power plus j omega, it is minus j omega. We multiply these all, and even this term over here and this term over here, and after solving we get this term, and it is one of the important problems. And these problems are on properties. So we'll see these problems in the next video. This is also one of the important problems. We'll see those in the next video.